This question is to calculate the marginal probability density function of a continuous random variable, x, given its joint probability density function with another variable, y. Let capital X and capital Y be two continuous random variables with a joint probability density function defined as follows. The density at a point x and y is equal to the quantity 1 plus sine of x times sine of y, all divided by 2 pi, multiplied by the exponential of negative 1/2 times the quantity x squared plus y squared. This formula holds for all real values of x and y. Now, the question is, what is the marginal probability density function of x? First step is to understand what we are finding. We're trying to find a marginal density of x. That means we will integrate the joint density function over all values of y, essentially collapsing the y dimension. Next step is to substitute in the joint density. So we substitute the given expression into our integral. That means we are integrating over all y, the quantity 1 plus sine of x times sine of y, divided by 2 pi times the exponential of negative 1/2 times x squared plus y squared. Next step is to factor out constant terms. Since x is treated as a constant when integrating with respect to y, we can factor out the exponential of negative 1/2 times x squared. That leaves us with the following. We multiply exponential of negative 1/2 times x squared by the integral over y, the quantity 1 plus sine of x times sine of y, times the exponential of negative 1/2 times y squared, all divided by 2 pi. Next step is to break the integral into two parts. We now separate the integral into two simple parts. The first part is the integral of just the exponential of negative 1/2 times y squared. The second part is the sine of x times the integral of sine of y times the exponential of negative 1/2 times y squared. Both are still over all real values of y. Next step is to evaluate the two integrals. The first integral is well known. It evaluates to the square root of 2 pi. The second integral is an odd function being integrated over a symmetric interval, so its result is 0. Next step is to combine the results. Now we plug everything back in. We take exponential of negative 1/2 times x squared, divide by 2 pi, and multiply by the square root of 2 pi for the first integral. This simplifies to 1 over the square root of 2 pi times exponential of negative 1/2 times x squared. So, the final result is, the marginal density of x is equal to 1 over the square root of 2 pi times exponential of negative 1/2 times x squared. This means that x follows a standard normal distribution. Final answer is, f of x equals 1 over the square root of 2 pi times exponential of negative 1/2 times x squared. Many students forget that the integral of sine of y times a symmetric bell curve is 0, since that's an odd function. Don't overlook symmetry when integrating. When finding marginal densities, always check if any part of the integrand is an odd function over a symmetric interval. That might cancel out and simplify the work a lot. That's it for this question solving. This video is based on our math tutoring blog and class recordings. Hope you enjoyed it. Please subscribe to our channel Math Tutor 80 to 85 and turn on the notification bell. Press the like button. Thank you so much.